Okay, complex fractions. I really don't know why they call this complex fractions. They should call it just the most greatest funness in the whole world. Because really, it's just a whole bunch of fun. If you agree, give me a like and share me on YouTube. I know that would be excellent. Of course, I'm just kidding. Don't be afraid of complex fractions. You can do this. It just takes a couple of steps and you will get the correct answer. Now look at what we got going on here. We've got this fraction added to this fraction, and their sum is being divided by this fraction minus this fraction. Why? Well, to get you to think, and also this might come in needful when you get to college, yes. In real life, maybe you'll have a job where you need to be able to understand this right here. Here we go. What to do? The first thing that I would suggest is forget about the bottom and just do the top. You're going to split this up into two different exercises to begin with. Then you will combine them and you'll be able to solve. If I think just about 1/5 plus 1/3, here we go. I need a common denominator. 3, you can't multiply it by anything to get 5, and 5, you can't multiply it by anything to get 3. Now you could just type that in your calculator, 1/5 plus 1/3, and you'd be done with this step. But for those of you who are purists that want to know what to do, multiply the top and bottom of this one by 3, multiply the top and bottom of this one by 5, then you'll have a common denominator and you'll be able to add them together. So 3 over 3 times 1 over 5 plus 5 over 5 times 1 over 3 equals. We do this one first. That gives us 3 over 15. Now, if you reduce that, you'll still get 1 over 5. So that shows us that we haven't changed anything about the value. This one gives us 5 over 15. Now we can add them together. Just add the tops, keep the bottom. 8 over 15. Now it's time to do the same thing to the bottom. Multiply this one by 6 over 6 and this one by 4 over 4. So 6 over 6 times 1/4 minus 4 over 4 times 1 over 6. 6 times 1 is 6. 6 times 4 is 24. Minus 4 times 1 is 4. 4 times 6 is 24. And now combine. 6 take away 4 is 2. And keep the bottom, 24. Now this one can be reduced to 1 over 12. And I think I'm going to go ahead and do that. If it couldn't be reduced, then we would go ahead and use it the way that it is. So what we have ended up with is 8 over 15 divided by 1 over 12. What you learned in the 6th grade was when you divide one fraction by another fraction, you invert and multiply. That means you flip the one on bottom upside down and you multiply. So this equals 8 over 15 times 12 over 1. See how we flipped the bottom one upside down, and now we're going to multiply. If you really like fractions, then you already see, hey, there's some reducing that can be done. You can reduce on the diagonal. I'm not going to do that. I don't want to mess anybody up. But this would, 3 goes into 12 and 3 goes into 15. That would make that 4 and that would make that 5. We don't have to do that. Just go ahead and multiply. Top times top, so 96. And bottom times the bottom, 15. Now we get our trusty old calculator. Turn it on, do 96 divided by 15. Math, enter, enter. That reduces to 32 over 5. Equals 32 over 5. You see the number of steps that it took me to do that. Not one of them was a difficult step. You can do this. Do the steps. Get the right answer. Now what if we have x in the mix then? Then we have a fraction being added to a whole number. Well, nothing really changes here. We're still going to split it up. Top, bottom, work them as separate problems. So I have 3x over 4 plus 1. I'm going to make 4 my common denominator. That means the first term, I don't need to do anything to it. The second one, how can I write the number 1 using 4s? Well, that's going to be 4 over 4. That is 1. Now I'm going to add 3x plus 4 over 4. Uh-oh, you say. You got this ugly thing as a solution for this right here? That's all right. That's okay. They keep me around. We're going to keep that ugly thing around. All right, now the bottom. Multiply the top and the bottom of this one by 7. Multiply the top and the bottom of this one by 3. So 7 over 7 times 2/3 plus 3 over 3 times 1 over 7. It doesn't matter which one of these you put in parentheses, it means times. So 14 over 21 plus 3 over 21 equals 14 plus 3 is 17 over 21. So here's the two fractions that we're going to work with. This one and this one. This one gets divided by this one. 3x plus 4 being divided over 4 being divided by 17 over 21. One fraction, one fraction. Turn this one upside down and multiply. 3x plus 4 over 4 times 21 over 17. Now you might be thinking to yourself, can you reduce this right here? And the answer is no. In order to reduce, all three of these values have to have a common number. 4 does divide into 4, but 4 doesn't divide evenly into 3. So no, you can't reduce that. Okay, I'm going to go down here now. So we have 3x plus 4 times 21. I'm going to write it this way. 21 times 3x plus 4. That goes on the top, and on the bottom, 4 times 17. Well, 4 times 17, I believe, is 61. And now, here we are. Distributive property, and we should be done. 21 times 3 is 63. 21 times 4 is 84 and the 61 on bottom. Can we reduce? Well, do 63, 61, and 84 have common factors? I don't believe so. We're going to call that done. Yes! Look at this beauty. Man, you search your whole life looking for sweetness like this, and here it is on a piece of paper. All right. Same process. Break these two up. And look what's going on here. I've got a 12 and a 4. You know what? There is something I can multiply 4 by to get 12. I can multiply 4 by 3 to get 12. So I'm not going to have to change this fraction in any way. I'm just going to change this one right here by multiplying the top and the bottom by 3. So we have 25 over 12 plus 3 over 3 times x plus 1 over 4. So 25 over 12 plus, do the distributive property, 3 times x is 3x. 3 times 1 is 3. And on the bottom, 3 times 4 is 12. Now here's a good example to show you when you can reduce with a complex fraction like this. 3 goes into 3, obviously. 3 goes into 12, and 3 also goes into this 3. In fact, it would give us this right here if we reduced it. But we changed it so that we could do this addition. 25 plus 3x plus 3. This is a constant. This is a constant. Those are the two that get added together. So 3x plus 28. 28 comes from 25 plus 3 over 12. Now if we check this again to see if it can reduce, 3 goes into 3 and 12. Yep. But 3 does not divide evenly into 28. 4 goes into 28 and 12, but 4 doesn't go into 3. So no, this can't be reduced. Now the bottom. Well, looky here. 18, 36. I know that I can multiply 18 by 2 and it equals 36. So I'm not going to change anything about this fraction. I'm just going to multiply this one on top and the bottom by 2. So 2 over 2 times 1 over 18 minus x plus 1 over 36. When I do this multiplication, I get 2 over 36. Take away x plus 1 over 36. Right. Watch how I do this. This x plus 1 here is actually in parentheses and is being subtracted. So the top of this turns into 2, take away x, take away 1. Over 36. This minus sign has to be distributed through this parentheses. These parentheses. Okay. 2 take away 1 is 1. So this is 1 minus x over 36. So here's our two fractions that we're going to work with. This divided by this. Flip this one upside down and multiply. 3x plus 28 over 12 times, flip this one upside down, 36 over 1 minus x equals. I'm going to come down to the bottom part of the paper. 3x plus 28 over 12 times 36 over 1 minus x equals 36 times 3x plus 28 being divided by 12 times 1 minus x. There's several ways we can go at it here. We can go ahead and multiply and then see if anything reduces. Look right here, 36 divided by 12. We could have reduced right here. We definitely can reduce right here. 12 goes into 36 3 times. So that gives us 3 over 3x plus 28 being divided by 1 minus x. With the distributive property, 9x plus, let's see, I believe that's 84 over 1 minus x. That is the answer. Bada boom, bada bing, we're done. Okay, you can look this up in the book, and it's not going to give you very many examples, literal examples like this one right here. But you can look it up in the book anyway. If my instructions and this video don't help you much, my suggestion is do it like this. Look at the top as a separate problem from the bottom. Work those down to two single fractions. When you divide a fraction by a fraction, you invert and multiply. It works on examples like this. There are some examples like this in the book. There are some examples like this in the book. But really, they jump to even more complex problems right away when you look up complex fractions in the book. So try to make sense of this. This will help you be able to do your next assignment, which is solving equations using this kind of funness. I hope everything's going well. Try your best. Please just send me your work back. Don't send me notes back. I don't need notes. It just makes me have to shuffle through a whole bunch of paper. Please don't do that to me. And I hope all is well and continues to go well. Bye.